Have you ever thought about this? We live in an age of AI, satellites, and supercomputers. And yet, in real life, you move into a brand new apartment, and a few months later, there's already a crack in the wall. The road outside your building gets dug up, filled in, and then a few months later, it gets dug up all over again. But now, go back 2,000 years. The ancient Romans had no modern machinery, no computer modeling, and they had never even seen a bag of cement. And yet some of the buildings and harbor structures they left behind are still standing today. Even crazier, when scientists took another look at Roman concrete, they found something strange. It wasn't that the concrete never cracked. It was that, in some cases, when tiny cracks appeared, the material could actually help seal them from the inside. Almost like a wound slowly healing itself. It sounds like some kind of alien technology. So what was really going on? You're about to find out. Let's start with the key point. What modern reinforced concrete really fears isn't just water itself. It's what happens when water seeps through cracks, carrying salts and air deep inside until it reaches the steel reinforcement. Once that steel starts to rust, it expands. And when it expands, it pushes the concrete apart from the inside. The cracks get wider, pieces start breaking off, and eventually the whole structure begins to deteriorate. Engineers often call this problem concrete cancer. And once it starts spreading, it can be extremely expensive to repair and very hard to fully stop. But some ancient Roman harbor structures sat in seawater for centuries, even thousands of years, and behaved in a completely different way. Logically, seawater should have destroyed them faster. But in some Roman marine concrete, seawater actually helped form new minerals, making the structure more stable over time. So what exactly did water do to it? The answer is surprisingly counterintuitive. Let me start with something you've probably experienced yourself. There's a road near where I live. It used to have 3 lanes. But after construction barriers went up, 3 lanes suddenly became 1. And those barriers stayed there for a long time. Every morning during rush hour, all the cars would be squeezed into that single lane. And to this day, I still don't really know what they were fixing. You say they were repairing the road, but it feels like as soon as it's repaired, it needs repairing again. And if they don't fix it, the surface really is full of cracks and potholes. And that's not even the worst example. Not long after our residential complex was handed over, decorative panels on the outside walls started falling off. One of them almost hit someone. In the end, the homeowners had to push back together and demand that the exterior walls of all the buildings be inspected and repaired. You've probably seen things like this too. A new apartment starts leaking not long after people move in. Cracks appear on the walls. The soundproofing is so bad you can hear your neighbor talking on the phone. The underground parking garage starts leaking. The shops downstairs are surrounded by repair barriers again and again. Honestly, we've almost gotten used to it. But here's the question. Is this really normal? We have better technology than ever before. More expensive materials. More precise drawings. More complex construction standards. So why does it often feel like things are getting newer, but not necessarily more durable? Today, this might sound like just another complaint about city life. But if you compare it with Roman concrete from 2,000 years ago, you start to see a much bigger question. Are we building things that are simply trying not to fail? Or are we building systems that know how to recover when failure eventually happens? Now, this next part is the most important part of the story, so listen closely. A lot of people have heard this explanation. Roman concrete lasted so long because it contained volcanic ash. And that's true. Volcanic ash was a very important part of Roman concrete. But today, we're not just talking about volcanic ash. We're talking about something else, something that was overlooked for a very long time. If you look at cross-sections of some ancient Roman concrete, you'll see little white chunks scattered throughout the material. They look uneven, almost like lumps of flour that weren't mixed properly. For a long time, when people saw these white chunks, the first reaction was, did Roman workers fail to mix the material properly? Were the ingredients poorly prepared? Was this just a sign of rough, primitive workmanship? In other words, these white specks were often treated as evidence of poor quality. And that's actually really interesting, because when we look at ancient technology, we often bring a hidden assumption with us. Ancient means backward. Ancient means crude. Ancient people built things mostly through manpower, luck, and brute force. So when we see these irregular white chunks, it's easy to think, look, they didn't even mix the concrete correctly. But in recent years, researchers from MIT and other institutions took another look at these white particles and proposed a very different explanation. These white chunks may not have been a mistake at all. They may have been one of the keys that allowed Roman concrete to repair itself. These white particles are mainly related to lime. More specifically, they may have come from a process called hot mixing. In simple terms, when the Romans made concrete, they may not have used only the slower, cooler mixing process that people once imagined. They may have added quicklime directly into the mixture, triggering high-temperature reactions that created these special lime clasts inside the concrete. And this process was not easy. It could even be dangerous, because when quicklime reacts with water, it releases heat and the temperature can rise quickly. If you don't know what you're doing, it can be hazardous. But because of this process, those white particles were left inside the concrete. They were like repair material embedded in the structure ahead of time. You can think of them as a kind of self-healing capsule, not because the Romans literally invented modern capsule technology, but because the role they played inside the structure was similar to little backup repair kits. Once a crack formed and water entered, those particles had a chance to activate. So the ancient Romans weren't lacking technology. It's more like we misunderstood where their technology actually was. We thought it was rough workmanship, but it may have been the cleverest part of the whole system. So how exactly did these self-healing capsules work? Let me explain it with a simple image. Imagine a Roman concrete wall. After years of wind, rain, heat, and stress, a tiny crack finally appears. Then it rains, or seawater splashes onto it. Water begins to seep into the crack. In modern reinforced concrete, this is often the beginning of trouble, because that water may carry salts and oxygen down to the steel inside. Over time, the steel rusts, expands, and pushes the crack wider and wider. But in some Roman concrete, the situation was different. When water entered the crack, it could come into contact with those white lime particles. Those particles would begin to dissolve and release calcium. Then, near the crack, new minerals could crystallize and slowly fill the gap. In some cases, this could form calcium carbonate. In other cases, it could continue reacting with components in the volcanic ash, creating new binding material. You can think of it this way. When a crack first appeared, water was not simply a destructive force. It was more like a key that unlocked a repair mechanism already built into the material. The whole process didn't happen instantly, but in experiments, researchers observed that samples with this mechanism could seal small cracks within a matter of weeks. That is the most counterintuitive part. For many modern structures, water is a warning sign. Once water gets inside, it can mean corrosion, expansion, falling concrete, and expensive repairs. But in Roman concrete, water became part of the repair process. The same water that can destroy modern structures became, in Roman concrete, almost like the needle and thread used to stitch a wound closed. Here's the line worth remembering. What made Roman concrete powerful was not that it never cracked. It was that it accepted cracks as something that would eventually happen, and it hid the repair material inside the body of the structure in advance. It wasn't fighting nature. It was using nature. It didn't assume that rain, seawater, vibration, and time would never arrive. It prepared a response for when they did. Pause for a second. If you think that idea is kind of brilliant, hit the like button. Because from here, we're not just talking about concrete anymore. At this point, I want to step outside the concrete itself and talk about something bigger. The modern world has a very different relationship with durability. Today, it's not always that things can't be made to last longer. It's that they exist inside a much more complicated system. Budgets need to be cut. Deadlines need to be shortened. Products need to be updated quickly. Maintenance gets outsourced. Responsibility gets divided across different layers. Every part of the process may have its own reason. But the result ordinary people feel is this. Things keep getting newer, but not always more reliable. Cities keep getting more complex, but when something breaks, fixing it seems to take longer and longer. Look at phones. After 3 to 5 years, many people already feel like it's time to replace them. Look at many household appliances. Sometimes the cost of repair is so high, you might as well buy a new one. Look at roads and residential buildings. Today, they fix this side. Tomorrow, they patch that side. The construction barriers never seem to disappear. This can't be reduced to one single person's fault. It may involve cost, profit, deadlines, regulation, maintenance systems, and many other factors. But you can't deny that, very often, our systems are better at repairing things after they fail than designing repairability into them from the very beginning. And here's the more uncomfortable part. A lot of hidden problems don't get taken seriously until something bad happens. If the wall panel doesn't fall, nobody treats it as urgent. If the road doesn't collapse, it can wait. If the apartment isn't leaking badly enough to make it unlivable, people are expected to put up with it. Many problems only become important after an accident. That's when people start fixing what should have been prevented earlier. And if there is no accident, things may just keep going the way they are. Now look back at the ancient Romans. They didn't have CAD drawings. They didn't have modern structural engineering software. They didn't have the precise testing equipment we have today. But in some of their materials and structures, they used a very different way of thinking. They were not only asking, how do we make this look perfect today? They seemed to be asking, if this thing cracks in the future, if it gets wet, if seawater hits it again and again, can it still hold together? That is a completely different way of building. One approach assumes things will eventually break, so they can be demolished and replaced. The other accepts that things can be damaged, but gives them the ability to recover. One is preparing for the next replacement. The other is preparing for the next generation. That's why Roman concrete becomes more fascinating the more you think about it. It's not simply telling us, ancient people were smarter than modern people. That would be too crude, and honestly, not accurate. What it really tells us is this. Technological progress is not only about building faster, taller, and more complex things. It is also about whether we have the patience to design the recovery mechanism before failure happens. After all this, let's bring it back to something more practical. This way of thinking doesn't only apply to buildings. It applies to us too. A person cannot avoid making mistakes forever. A team cannot avoid problems forever. A city cannot avoid breakdowns forever. A company cannot avoid crises forever. What really matters is not pretending that cracks will never appear. It is thinking ahead about what to do when they do. For example, when you make decisions, you're going to get things wrong sometimes. So do you have a review process? Do you have a signal that tells you when to stop and rethink? Do you have a habit that catches small mistakes before they become big ones? The same is true for a team. Problems are not the scary part. The scary part is when every problem becomes an emergency. When every crisis depends on one person carrying the whole thing. When every issue is ignored until it becomes too big to hide. A truly strong system is not one that is so perfect it never cracks. It is one that already has a response ready when cracks appear. That is what truly amazes me about Roman concrete. The fact that it lasted 2,000 years is only the result. The real core is the thinking behind it. It tells us, don't worship the idea of never breaking. Learn how to design for recovery after something breaks. Sometimes real sophistication is not about hiding the problem. It is about admitting that problems will come and building the repair mechanism in advance. All right, that's it for today. But before you go, I want to ask you one question. If our cities became ruins 2,000 years from now, what do you think would still be left behind? A bridge that is still standing? A building whose structure can still be recognized? Or just piles of trash that still haven't broken down? Tell me your guess in the comments. I'm genuinely curious. If this video gave you a new way to think about things, hit the like button so more people can see it. And consider subscribing. Next time, we'll look at another thing that sounds completely ordinary at first, but once you really think about it, feels strangely wrong. See you next time.